Hey guys, today we're going to be talking about the unit circle and how I can use points on the unit circle to find values of sine theta, cosine theta, and tan theta. So the unit circle is a circle drawn from the origin, so centers at the origin with a radius of 1. If I pick a point on the unit circle and name that point x, y, I can draw a triangle starting at origin to the point xy and then down to my x-axis. The angle formed by the hypotenuse of that triangle and the x-axis, I'm going to call theta. If this is the point xy, that means this length here is x, this length here is y, and then since this is the unit circle, that means the hypotenuse is equal to 1. Using SOHCAHTOA with these points, now I can find each of my 6 trig functions. So I know that sine theta is equal to the opposite over the hypotenuse. So in this case, that's y. Cosine theta is equal to the adjacent over the hypotenuse, which is x over 1. So that's just x. And tan theta is equal to opposite over adjacent. So that's y over x. My reciprocal trig function, so the reciprocal of sine is cosecant. So cosecant is equal to 1 over sine theta. So in our case, 1 over y. Secant theta is equal to 1 over cosine theta. So 1 over x. And cotan theta is equal to 1 over tan theta, or y over x. So on the unit circle for any coordinate xy, I can write that as cosine theta, sine theta. Now that I know that xy is equal to cosine theta, sine theta, I can use this to determine which of my trig functions are positive and negative in each of the quadrants. So for example, if I pick a point on the unit circle that's in the second quadrant, say I pick this point. This point has a negative x coordinate and a positive y coordinate, right? Because I went left and I went up. So if I were to look at sine theta in this quadrant, since sine theta is the y coordinate, sine is positive. Since cosine theta is the x coordinate, cosine would be negative. And since tan is y divided by x, this would be a positive divided by a negative, so it would be negative. So the only thing that's positive in this quadrant is sine. If I pick something in the third quadrant, so say I pick this point, this coordinate would be negative x, negative y, right? Both of these would be negative because I went left and I went down. So if I look at sine theta in this quadrant, sine would be negative. Cosine theta would be negative. Tan, a negative divided by a negative, would be positive. So the only thing positive in this quadrant is tan. And then if I look at my fourth quadrant, if I pick any point on that unit circle, this is now going to be a positive x coordinate, but a negative y coordinate. Sine theta is equal to y, so that's negative. Cosine theta is equal to x, so that would be positive. And tan theta, it would be a negative divided by a positive, so that's a negative. The only thing positive in this quadrant would be cosine. This idea, sine is only positive, tan is only positive, and cosine is only positive, you've seen before in Algebra 2 as all students take calculus or whatever acronym your teacher had given you. This tells you which functions or which trig functions are positive in each of the quadrants. So in the first quadrant, all of the trig functions are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cosine is positive. Now that I know how to use the unit circle to find values of my trig functions, let's do some examples. Number 1, if point P negative rad 3 over 2 comma 1/2 lies on the unit circle, determine the following. So we just learned on the previous page that the coordinates x, y, if located on the unit circle, is equal to cosine theta, sine theta. So if I'm looking for sine theta and this point lies on the unit circle, I'm just looking at the y coordinate, so that's a half. Cosine theta is my x coordinate, so that's negative rad 3 over 2. And tan theta is always y over x, so sine theta, 1/2 over cosine theta, negative rad 3 over 2. I'm not going to leave that as a complex fraction, so I'm going to keep change flip. I end up with negative 1 over rad 3. I'm going to rationalize by multiplying by rad 3 over 3, and my final here is negative rad 3 over 3. For my reciprocal functions, I just need to flip. So cosecant is the reciprocal of sine. If sine was 1/2, that means cosecant is 2. Secant is the reciprocal of cosine. So if I flip this guy, I get negative 2 over radical 3, which I am going to rationalize. So I'm going to multiply this function by rad 3 over rad 3. I get negative 2 rad 3 over 3. And then for my last example, cotan, I'm going to look at my answer from before I rationalized it, which was negative 1 over rad 3. So if I flip that, I get just negative rad 3. So I don't have to re-rationalize, if you will. Number 2, if cosine theta is negative 5 over 13 and sine theta is less than 0, find sine theta, tan theta, and cosecant theta. By telling us that cosine is negative and sine is negative, this is a tricky way of telling me what quadrant theta is lying in. So if I set up my little all students take calc graph, if cosine is negative, I cannot be in quadrant 1 or quadrant 4. And if sine is negative, I can't be in quadrant 2. So the theta that they're talking about must be in quadrant 3. So what I'm going to sketch right now is a triangle in quadrant 3, where theta is the angle formed with the hypotenuse and the x-axis. And I can fill in sides of these triangles using SOHCAHTOA, kind of like I did all in the beginning when I was talking about the unit circle. So I know that cosine is equal to adjacent over hypotenuse. So the adjacent side next to theta is going to be 5, and the hypotenuse side is going to be 13. I know that this is a Pythagorean triplet, so this opposite side must be 12. Since this is a left distance from the origin, this is going to be negative, this is negative, my hypotenuse always stays positive. So now when I find sine, tan, and cosecant, I can find each of those using my little diagram that I've now created. So sine is opposite over hypotenuse, so that's going to be negative 12 over 13. I'm in the third quadrant, so that makes sense that sine is negative. Tan theta is opposite over adjacent, so negative divided by a negative, that's just going to be positive 12 over 5. Again, makes sense since I'm in the third quadrant. And then cosecant is the reciprocal of sine, so I'm going to take part A and flip it over. I get negative 13 over 12. Let's do one more like this. Number 3, if sine theta equals negative 2 over 5 and tan theta is less than 0, find cosine theta, tan theta, and secant theta. I'm going to do the same thing I did in the previous example. I'm going to figure out which quadrant I'm in first. So sine's negative, I cannot be in the first quadrant or the second quadrant. And if tan's negative, I can't be in the third quadrant. So this angle theta must be in the fourth quadrant. So now if I set up a triangle in the fourth quadrant, theta is here. They told me that sine is negative 2 over 5, so that's opposite over hypotenuse. So opposite theta must be 2, and the hypotenuse side must be 5. This is going down from the x-axis, so this is negative 2. And looking at these numbers, this is not a triple. So I'm going to need to use Pythagorean's theorem to find this third side of the triangle. So I can say that 2 squared plus x squared is equal to 5 squared. So x is going to be equal to the square root of 21. So I'm going to fill that in here, rad 21. Now I can find each of my functions up here. Cosine is equal to adjacent over hypotenuse. So that's rad 21 over 5. Tan theta is equal to opposite over adjacent. So that's going to be negative 2 over rad 21, which I'll rationalize by multiplying by rad 21 over rad 21. That gives me negative 2 rad 21 over 21. And lastly, secant theta, that's the reciprocal of cosine. So that's going to be 5 over rad 21. And again, if I rationalize here, I end up with 5 rad 21 over 21.